In this video, I will share an experiment to study variation in intensity of magnetic field due to a current carrying coil along axis of the coil. A current carrying coil behaves as a magnetic dipole with one face as north pole and the other face as south pole. Direction of magnetic field due to a current carrying coil is perpendicular to plane of the coil, and magnitude of magnetic field on the axis of coil is given as B equal to mu naught upon 4 pi 2 pi n I r square whole divided by r square plus x square raised to power 3 by 2. In this relation, mu naught represents permeability of air, N is number of insulated copper wire turns in the coil, I represents current flowing in the coil, capital R represents radius of circular coil, and capital X is distance of point of observation from center of the coil. This experiment is based on tangent law, according to which if a magnetic dipole is freely suspended under the influence of two mutually perpendicular external magnetic fields B1 and B2, then at equilibrium, length of the dipole makes an angle theta with B2 such that B1 is equal to B2 tan theta. In this experiment, the magnet is under the influence of magnetic field due to current carrying coil B and horizontal component of Earth's magnetic field B with subscript H. The current carrying coil is so positioned that plane of the coil is parallel to horizontal component of Earth's magnetic field. Thus, magnetic field due to current carrying circular coil B and horizontal component of Earth's magnetic field BH are perpendicular to each other. So, at equilibrium, length of the magnetic needle will make an angle theta with BH such that B is equal to BH tan theta. As BH has a constant value, so magnetic field due to current carrying coil B is proportional to tan theta. Thus, variation in magnetic field due to current carrying coil B is same as the variation of tan theta with distance of point of observation from the coil. This is the required circuit diagram to study variation in intensity of magnetic field along the axis of a current carrying circular coil. Let me introduce the apparatus. This is a rheostat. This is one-way key. This is battery. This is ammeter. This is circular coil through which current is passed. This is magnetometer box having a small magnetic needle. Adjust the position of horizontal frame in such a way that plane of the coil is roughly in north-south direction of Earth. Slide the magnetometer box so as to make magnetic needle coincide with the center of the coil. Make various connections in accordance with the circuit diagram. Rotate the magnetometer box until the pointer coincides with 00 line of scale provided along the boundary of magnetometer box. Adjust the value of current so that pointer in magnetometer shows a sufficiently high deflection. By sliding the magnetometer box to different positions on both the sides of coil, note deflection of pointer as theta. Calculate tan theta for each observation and plot a graph of tan theta versus distance of point of observation from the coil. As the magnetic field due to current carrying coil B is proportional to tan theta, so graph of magnetic field B versus distance of point of observation from coil will be similar to the graph of tan theta versus distance of point of observation. Thus, it can be concluded that intensity of magnetic field B due to current carrying coil is maximum at the center of the coil and goes on decreasing as we move away from the coil on left side or on right side of the coil. Thank you.